Hello everyone and welcome to my channel. So in this video, we'll be practicing aggregate functions of SQL. So we will be exploring count, sum, min, max, average, group by, having, case, distinct. So these were the functions which we explored earlier in our theoretical video. And in this video, we will be practicing and implementing these functions. So we will practice and solve problems which are mentioned on this website. So let's try it out first. So first we have count. Let's try it out and open another tab. So here the question is, write a query to count the number of non-null rows in the low column. So we have a column called low and we have to count the number of non-null values. So it will be easily query using count function. Just write it out. Like count low low from copy this database name. Let's run it out. And we have got the low value, which is 3535. Same can be done on high column. We have a low value in high column 353. So it's good to go to the next problem. Next problem states that write a query that determines and counts of every single column. It means we have to write a query and count each of the single column. And with these count, can you tell which column has the most null values? Okay, let's try it out on this column. So we have already done for low. Let's try it on. So we have 3236 and your month open, not done. Let's try it out for open column. Yes, we have. Let's run. Okay. So it looks like the high column have the lowest all null values. The highest one is, I guess, month, rows, year. That's it. So let's see the answer. Um, we have write the correct statement or not? Yes, we have correctly write the query. Moving on, let's jump on SQL sum function. So in this problem, we have to write a query that calculate the average opening price, which means we have a column called open, and whenever we say average, we need to sum the value of those columns and then divide it by the count of all those values which are non-null in that column. Let's try it out. So we have to count the average open price. This will be open and average and sum of n. divide by count. I guess we are good to go. Oh, sorry for the mistake. Let's check the answer as well. So this is the average and it's the answer. So yeah, we have written the correct statement. Now let's jump to in max. So in this query, we have to find out what was the Apple's lowest stock price. So we will be using two column, and in that we will use a minimum function because it's clearly says that we have to find the lowest stock price. Minimum low from. So the answer is 6.36 is the lowest price of Apple stock. Now let's find out what was the highest single day increase in Apple's share value. So in this problem, we have to find the maximum, but we have to first take a difference between the close value on that specific day and the open value. So we think about that the market or the day at which this Apple price was open, the price of that value, and then subtract it with the close value at which the volume or the value was closed at the end of this day. We will be using the max function. We will first we will subtract close and then from open. So take a difference between close and open and find out the max value of all those values. So yeah, 32.58 is maximum. Let's check the answer. I guess we have written the right statement. Yep, maximum of close and open difference. We are good to go. The next problem. And the next problem is average. And write a query that calculates the average daily trade volume for Apple stock. Okay, we have to find the average daily trade volume. So we will use average and then take an average of volume column. Let's run it out and check the answer. So yeah, we have written the correct statement. The difference, the normal difference, the slight difference that we they have used the alias as well for this average volume, but we have written the correct statement. Now let's jump to group by. So in the first query of group by function, we have to write a query that calculates the total number of shares traded each month. So it looks like we have to group by on the basis of month and order your results chronologically, which means we have to order by year or month, whichever mentioned in the query. Let's try it out. Let's check this thing from and we have to select, we have to calculate the total number of shares traded at each month. So we have to find the sum of volume. Basically, it contains the total shares of that particular stock. And then we have to print month, then group by and then order by, because it says that we have to order by as well. Yes. The query works exactly fine, and we can see for each month the volume of specific the result, which says that the total number of shares. So in the first month we traded this number of shares. On the second month we trade this number of shares, and still goes to the 12th month, which is December. We can also do add one thing, and that is year, and then remember that we have to group by as well, first by year and then month, then order by according to it as well. Sure. So basically it will first group by one year, and it will shows for all month of that specific year, and then move towards the next year, which is 2001, and then its specific months and its specific volume or total number of shares. That's how you write a query. Moving on to the next problem. In this problem, we have to write a query that calculate the average daily price change, means we have to use average. And since it says that daily price change, so we have to use close and as well as open, both of the rates, because that determines the whole price change for each day of that particular stock. And then we have to group by year. So in this we will not be needing month from here, then we will be needing, but we will be needing average, then close minus open rate, average value, and I guess we are good to go. Let's run it out and see the answer as well. So for each year we can get its average value. Yeah, we have implemented, right. The difference is that they didn't mention the name, they use numbers, and we can do that as well. I have written group by year, but you cannot group by one, which clearly link with year. So let's try another example or problem. Write a query that calculates the lowest and highest prices, which means we have to use maximum and minimum in this. Then by month we have to group by. Let's try it out. Year, month, max, and minimum. Minimum of low, which defines the lowest price, and the highest price will be in highway column. Just group by 1, comma 2, 1, comma 2. Let's run it out and check the answer as well. So for each year and month, we have got its lowest and highest values. So yeah, we have implemented that right. Let's now jump to having SQL having. So having doesn't have any problems or practice problem to solve, but it does have a query clause order, which states that how you will be writing the query if you are using having. Because remember that whenever we group by, and if we have to apply a filter or condition, we have to use having. So select from and then where, and then after group by, if you have to filter out again, you need to use having and then group by, order by. And SQL case does have lots of problems. Let's try it out one by one. So in this first query we have to write a problem or query that includes a column that is flagged at yes, which means we have to define a condition in before from keyword. And then when a player is from California, we have to sort the results with the player first. So we have to flag it yes if the player is belong from California, otherwise ignore it, then sort the result based on that player. So let's try it out. Call, take the database and column, and first see all those columns which are in this table. So we have got school name, full school name, player name, position, height, weight, year. JR is for junior, SO I guess for sophomore, and then we have senior. Hometown, state. Okay. In this we have to write a query that is flag yes when a player is from California. So let's first select uh, player name, full name, height, H, H, G, and then our case statement will be here. Case when state is equals to the A, which means California, then flagged it as yes, else, null, and so remember whenever we use case, we have to end it with a and keyword, and let's name it as from CF, which means California. Let's try it out and some just to make it more presentable or readable. So there, and let's check the answer as well. What we are expecting is that four columns: player name, school name, height, and from CF if he is from CF. But it looked like doesn't belong to CF. Hmm. And have written correct statement, and we didn't order by. So there was a statement at the end which states that we have to sort the results with those players. A by from CF. So we have some players that belong from California all the way down. So yeah, we have done the correct statement. Now let's jump to the next problem. And in this, I guess we will be using some ranges. So they already mentioned that they have categorized the weight into different ranges like over 250 between 121 and 250 between 176 and 200 and 175 or lesser. So it depends on us how we wanna characterize the numbers. So in this, we have to write a query that includes player names and column that classify them into four categories based on height. So rather than weight, we are using height. Keep in mind that the answer we provide is only one of many possible answers. So we can divide into multiple ranges. That's what they meant. So let's write it out like player name, height, and as you can see, we can characterize into like let's say greater than 75, and let's remove it. When height is greater than 75, then our 75 limit, or sorry, valued as 475, and height is greater than 70 and height less than equal to 25, then 70, 75. Else under 70 and named it as height ranges. We don't have to order, just have to put it with and run it out. Hmm. Syntax or near there. So in this, we are creating three ranges: over 75, between 70 and 75, and under 70. Yes, we have implemented right. 67 is under 70, over 75 is 78, 71 is between 70 and 70. So it's fine. Now let's jump to another problem. In this query, we have to select all the columns. Let's first select all the columns, select everything, comma. Now write a case statement that adds an additional column that displays the player name if that player is a JR or SR, which means junior or senior. So select and create another column using case when year in, since it's two values, so we can just give it two values. JR, say SR, which means senior, then player name, there, year, else, null, and as player class. Oh, sorry, we have to input the player name. Oh, sorry, we have to return the player name. So we have to use player name when when we say then. So when a year is in JR or say SR, we have to get the player name. Else end it and tag that column as player class. Let's run it out. So this player is JR is here and its player name is Raf something. Same goes for SR, JR. So wherever JR or SR is coming in the year column, we can see its player name. It's good. So moving on, in another problem, we have to write a query that count the number of 300 LP plus players, which means we have to use wait column for it, and we have to divide the regions into West Coast, Texas, and other. So we have to write a case statement here as well. Let's try it out. Select case when region, oh sorry, state in CAOR and WAOR and WA, then st- when state Texas, then mark it as Texas, else other, and as from from game be college players where weight weight is greater than equal to 300, then just group by with regions. Spread it out. So here we first write the case statements, divide the regions into different uh, and divide the states into different regions, and then we just get all the values which have weight greater than 300, and then just group by or column. Let's check the answer. Yeah, so we have written it right, but we have to count it. So we have to count the number of players. So that let's count the first column as s- s- hmm. So for each region, we have got the players, the total count of. Now let's jump to another query. Write a query that calculate the combined weight of all the underclass, which they termed as FR and SO in California, as well as the combined weight of upper class, which is GR and SR. So we have to use year for it for in this query, the year column, and we have to sum the weight for those of for those players, the class players. So in this, we will be using year in FR and SR, R and S to mark as year plus else year in SR or JR. Then plus else null and classes. Sum of weights, since we have find the combined weight, sum it weight marked it as combined weight. Move this, and the state will be California, CR, sorry, CA, and then just group by classes. It should work, I guess. Yep. So in the underclass, the maximum weight is the total. So the sum of the weight is 2,774. The upper class weight is lesser than the other class. Let's check the answer. So we have year, then underclass, then year, then upper class, then sum of weight, then state, and then group by. So yeah, we have written the right sheet. Moving on to the next problem. Write a query that displays the number of players in each state. We have to count the player for each stage and the separate column for the total number of players. We have create 5 columns. Order the results such that the states with the most players come from order by as well. Let's try it out. Case when since we have to apply case and we have to count it as well. So first count and then case. Remove it out. case when year equals to fr, then 1, because it will basically write an increment and just sum all those values wherever the year is 1, and then just it will give us the total count for it. Else null. And we have to write different cases for each of those states, and it will be just one case and just else will be null. Or count is when so, then 1, else null, and as so count. Let's copy it out and put it here. JR for junior, R for senior, JR, SR. Then we have to total get the total count as well, so that if sum all those individual count for each states, we should get the total count. Total pairs group by state, order by total pairs, order by pairs desk, so that the number which have a higher or maximum as compared to other states should be customer. Total play doesn't exist. To F count, we have got the 5 columns: FR count, SO count, JR count, SR count, and total players. Sum it up, should get this. Check it out. 311205 means 500, 516, 16, and then 9, which correct. Let's check the answer. So case when year is FR count, players, group by state, order by desk. We have returned the document. Now let's jump to last problem of SQL function. Write a query that shows the number of players at schools where the name that starts with A to M. The number at schools where name starts with N, Z. So the case statement should be involved in this query, and it does have 3 conditions. Let's try it out first. Select case when the name is less than N, then A M, when school name greater than equal to N, marked it as N, that else null, and else group, get the total number of players or count of players. Will just group by first one. Don't have to order in this query, and we are good to go. check the answer. For the column players, name should start. We have written the a case statement and then we have mentioned the other statement as well. Yeah, NZ 125121378 We have got the group and the total count of each those group. Write the correct statement. Yes, we did. Great. Now let's jump to the last SQL testing lesson in all this practice problem. Write a query that returns the unique values in year column in chronological order. Stock price, distinct year column, distinct year, unique values in distinct year from provide. Let's check the answer as well. Like distinct year, order by year, distinct year, order by year. So let's try another problem or the second last problem for this lecture. Write a query that count the number of unique values in the month column, count distinct month, and then we have to group by for each year. Okay, select count year, then count distinct month, month count, then from group by first one, the name of people. Let's check the answer. It does run successfully. So for each year we have got count. Active count. So they have also order by as well. Just compare both of those statements. We have written the right. We have written the right statement. So now the last problem we have to write a query that separately count the number of units in the month column and the number of unique values in the year column. So we both year year count, month count, and we don't have to group by. Check the answer. It does run successfully. So year count, month count, count distinct year, count no distinct month. So there you go. So I hope you have learned from this practice sessions. We have implemented the count, sum, min, max, average, group by, case, distinct, all those intermediate as all those keywords or you can say functions which are part of intermediate SQL. In the next video, we'll be implementing and practicing problems from joins. Till the next video, take care.